Okay, we're ready to talk about the coefficient of determination. Coefficient of determination, a measure of the proportion of the variation in y that is explained by x, or the regression model. So let's read that again. A measure of the proportion of the variation in y that is explained by x, or the regression model. So let's just recall, in that prior video, we were looking at these scatter plots. We showed this top plot showed the total dispersion in x, so any individual value of y, our response value, how far away it is from its mean. We represented that by these lines here. And we determined that, well, that total variation can be broken into two parts. One is explained by the regression, so how far away is any point on the regression line away from that overall average. And then our unexplained variation, which is how far is any point away from our actual regression line. So the coefficient of determination is just trying to determine what proportion of that variation in y is explained by x. So basically, what proportion of the overall variation here can be explained by this portion here. So we generally will just call this r squared. You'll hear me just refer to this. I don't call it coefficient of determination. You'll just hear me say r squared. I'll usually write it this way, which is r squared is equal to the sum of squared residuals divided by the total sum of squares. So this should make some sense. In our denominator, we have the total variation, the total sum of squares, and we're seeing what proportion of that is from the regression model, the regression sum of squares. So we could equivalently write it as 1 minus the error sum of squares over SST, so this is a second way to do it. But for the most part, or pretty much any time, we'll use this first equation, as it also makes the most intuitive sense if you think of it as a proportion. What proportion of this overall variation is explained by the regression model. So note that r squared will be between 0 and 1. So the closer to 1, that means a greater proportion of the variation in y is explained by the regression model, and values closer to 0 means most of the variation in y is explained or is unexplained. It comes from our residuals. So we could also, there's a third way to calculate it, which is that we just take the square of the correlation r. So recall, correlation is between -1 and 1. So if you square it, you actually get the coefficient of determination. So as we already said, values closer to 1 indicate a better model fit, because more of the variation is explained by the regression, and values closer to 0 indicate worse model fit, because it is unexplained. So let's go ahead and return to our running example. So this was all calculated with Excel. Like I said, we will not be doing calculations by hand when it comes to sum of squares. But let's go ahead and calculate correlation, or sorry, not correlation, r squared. So r squared, as we just said, is the sum of squared residuals divided by the total sum of squares. Okay, so we would just plug in, which would be 678.37 divided by the total sum of squares, which is 1126.05. So that's this number and this number. So notice that the total sum of squares, we just summed up the error sum of squares, and we summed up the regression sum of squares. Okay, so when we do that, we get a value of about 0.6. So how would we interpret this? We would say 60% of the variation in, recall our y variable here, in miles per gallon, can be explained by horsepower. So we might say this is moderately good fit. I mean, it's not very close to 1, but it's above 50%, so let's just say it's moderate. These are all subjective words, but if it was very close to 1, we would say it's a good model fit. If it was close to 0, we would say bad model fit. So I'm kind of saying any middle values, we can call that moderate. Okay, and then let's just calculate this the other ways. Like I said, we really will only do it this way, but just for the sake of completeness, let's go ahead and do it the other way as well, which is r squared is equal to 1 minus SSE over SST. And so that would be 1 minus 447.67 over 1126.05. And this would be 1 minus 0.4 or 0.6. And then finally, our third method, which is just taking the square of our correlation. So if you remember, our correlation was negative 0.78. So if you just square that, if you do r squared is equal to negative 0.78, and we square that, you always get a positive value, and in this case, it would also give you 0.6. So that's coefficient of determination, the proportion of the variation in y that is explained by x, and we will typically use this formula here.